Pure Maths 1 students, we're on week 17 of our maintenance, looking at a quadratics question to start off with. We have to express 2x squared minus 4x plus 1 into this form here, so obviously we need to complete the square, and then we're going to state the coordinates of the minimum point, which we'll call A. Okay, so I'm going to factorize out first of all the 2. And then I can, within the square bracket, complete the square. And that leads me to 2 bracket x minus 1 all squared, minus 2 plus 1, which gives me minus 1. So obviously timesing that by that, minus 2 plus 1 is minus 1. And then we can say therefore the minimum point A is at 1, comma, we're looking at what does x need to be to make that bracket equal to 0, so that's the x coordinate, and then we put the x coordinate, oh, we don't need to put the x coordinate, this is going to be our y coordinate, so 1 minus 1. Perfect. Okay, that's that one. Now we've got this line meeting a curve. I'm going to rewrite my line as y equals x minus 4. Just rearrange that. And we want to see it intersects this curve here at points P and Q. We've got to find the coordinates of Q. So what I'm going to do is I'm going to set the curve, which is this, equal to the line, which is this. I'm going to bring everything across to one side. So I get 2x squared minus 5x plus 5 equals to 0. And hang on, is that correct? Oh, I've made a mistake there. Yeah. So I think I should have this, because that 4 is originally on the same side as the x, so that should be plus 4. So this is plus 4, which makes a bit of a difference here. Oh, for some reason I can't use it. Okay, there we go. So this will give us minus 3, and that is a different proposition. So we're going to have 2x and x here. Now we need to get negative 6, so 2 times negative 3 is negative 6, and we've got a plus 1 here. That should be equal to 0. Therefore, the roots of the equation are x equals negative 1/2 or 3. Now we can rule out the 3 because that you can see is the coordinates for P. So let's chuck in y equals, I'm going to use this equation here, negative 1/2 plus 4 equals 7/2. So the coordinates are of Q, negative 1/2 for our x value and 7/8 for our y value. Super duper. Moving on to the next one, the transformation that we're using here. Let's look what we've got here. So this remains the same in both cases, but then you've got 4 here, a 4 there, but you've got nothing here and a positive 2 here. So it looks to me like what we're doing is, if the original is x squared plus 2x minus 5, it looks to me that we're doing f2x, so that'll be 2x squared plus 2 into 2x minus 5. So if we're doing f2x, this is therefore a Plus or minus the square root of -1, but there's no real solution to that, so we can ignore that one. And sine theta equals plus or minus the square root of 1/2, square root 1/2, 45. And I guess if we're thinking about our graph here, we've got one here, we should have one here. So 135 is our other one. And then we need to do the negative version. So inverse sine of negative square root 1/2, which gives us negative 45, which is over here. So you can see you can have 2 here. So to get 360, which will give me this one here, which is 315. And then you go, well, it's 45 from here to here, isn't it? So it should be 45 from here to here. So you just go 180 plus 45, which is 225 degrees. So that's that one sorted. Okay, so moving on to a series question. Got to find the coefficient of x in this expansion. Okay, well, what I like to do is just sort of test what happens. Let's do our first one. So it'll be 7 choose 0 times x to the power of 7 times 2x to the power of negative 2 to the power of 0. So obviously you're going to get an x to the 7 kind of result here. Then the next one will be 7 choose 1. You'll have x to the power of 6 into 2x to the -2 to the power of 1. Now you're going to have 6 take away 2, so it'll be x to the power of 4 here. You're losing 3 each time, so it's the next one that we want, because we're wanting x to the power of 1. So this is the one we want. 7 choose 2, x to the power of 5 into 2x to the power of negative 2 all to the power of 2. Now, so we get 7 choose 2, which is 21, x to the power of 5, times, now this will be 4 over x to the 4. And I guess we can say, well, that's like 4 times 21, which is 84, x. And so the coefficient, of course, is 84. Okie dokie, differentiation question. we've got this curve with this equation here, and we want to find the set of values for x where the gradient of the curve is less than 5. So first of all, we're going to find f prime x. We differentiate, so we get 3x squared minus 4x plus 1. And we want to know where this is less than 5. So we go 3x squared minus 4x plus 1 is less than 5. Bring across everything to the left-hand side. And at this point, we've got to determine, what do we do here? I think we can factorize. So I could go 3x plus 2, bracket, 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 x minus 2 is less than 0. Now, we can do a quick sketch. We've got a root at negative 2/3, which is here. Negative 2/3. And we've got a root at 2 over here. And so you've got an equation that looks, this is your gradient equation, and we want to know where the gradient is less than 5. So it's this bit here, because remember we brought the 5 across, so we then made it less than or equal to 0. So we're looking at that bit there. So our answer, of course, is negative 2/3. We're looking at a range, so less than x less than 2, and we're done. Now, last question is find the values of fx at the two stationary points on the curve and determine the nature of each stationary point. So stationary points occur when the gradient is equal to 0. So I'm going to make this equal to 0. And we can just go, well, this is like minus 1, x minus 1 equals to 0. So when x equals 1/3 or 1, at x, so then we can just say f 1/3, and we plug 1/3 into the equation. Now 1/3, when we plug that into the equation, I think we get 4/27, and then f1, so obviously into the original equation, right? F1, now that's 1 take away 2, plus 1. I think that's negative 1. I think it's 0. Just check on that. So 1/3, I'm going to do both of them cubed. Take away 2 times 1/3 squared, so 2/9, plus 1/3. So 4/27 is right. 1 take away 2 plus 1, I think it's 0, the second one. And now to determine the nature, so we can do the second derivative, which is simply 6x minus 4, and we just pop these in. So f double prime 4/27 equals, oh, not that. We're going to put in the, sorry, we're putting in this 1/3 first. So we get 6 times 1/3, which is 2, take away 4. This will give us, wake up brain, 1/3, and this will give us, therefore that one is our maximum point. And then I guess we'll do the same with this one here. So f double prime 1 equals, so 6 take away 4 is 2, therefore that one is our minimum point. And there we go, we're done. Well, I hope this has been helpful to you. I didn't really feel onto it today with this one, so if I've made any mistakes, do let me know, because I feel like there could well be. Alright, hope this has been helpful. Let me know if you've got any queries. Take care. God bless.